Hello, and welcome to the Argyle AI Summit, Scaling AI for Impact. My name is Michael with Argyle. It's great to have everyone joining us today. I have some important information to share with you, and then we'll turn the floor over to our esteemed opening keynote speaker. First, we'd like to take a moment to thank today's sponsor, Newbird AI. Our sponsors are committed to providing you with valuable content and a great overall experience. At any time during today's event, you can visit their virtual booths from the main agenda page, which include complimentary materials, information, and meet and greet opportunities. We also welcome you to stay socially connected during today's event. For those of you who are active on social media, please use the hashtag ArgyleDigital and follow us on X at Argyle Exec Forum. Also, be sure to subscribe to Argyle on YouTube for exclusive access to all our past events. Finally, and most importantly, we want to hear from you. So during each session, we encourage you to submit your questions and comments in the Q&A box on your screen. Following each presentation, we've set aside time for our speakers to weigh in on your questions. Thank you again for joining us. Let's get started. Without further delay, I'd like to introduce our speaker, Ritvik Shrivastava, Technical Lead Multimodal AI with Meta. We're excited to have Ritvik for his opening keynote presentation titled From Pilots to Production, What It Really Takes to Scale. Ritvik, thank you so much for being here today with us. Welcome, and over to you.
Thanks, Michael. Good morning, everyone. It's great to be here. First, thank you to the Argyle team for having me, and thank you to everyone for joining this opening keynote at the Argyle AI Summit. It's a pleasure to be a part of the conversation that is moving from AI ambition to AI execution. Over the last few years, AI has moved from something organizations were watching closely to something teams are actively applying across products, operations, finance, engineering, and customer experience. My core argument today is simple. The next AI advantage will come not from running more pilots, it will come from building systems that allow AI to operate reliably in the world. Every company now has an AI pilot that they're proud of. It can be a summarizer working on clean examples, a co-pilot that gives impressive answers, or an agent that completes a narrow happy path workflow. And to be clear, this is all great real progress. The pilot phase has been super valuable. It has helped teams to build intuition, help executives and operators see what's possible, and it's helped organizations move from abstract curiosity to tangible use cases. But production is where the distribution changes. The examples are no longer clean, the users are not handpicked, the workflow is not narrow, the context may be incomplete, the tools may fail, or the permissions, latency, cost, and all these risks start to matter a lot more. And now the output may affect the actual customer, an employee, a transaction, or worse, a business decision. So the question is no longer whether AI can do something impressive just the one time. The question is whether it can survive come Monday morning. That's when the real users, data, and constraints start showing up. That is the shift from pilot thinking to production thinking. So this data, it reflects the tension pretty clearly. Adoption is no longer a scarce thing. According to McKinsey's State of the AI Research Report from 2025, almost all survey respondents say that the organizations are using AI in some form or the other. Nearly 2/3 have not yet begun scaling across the enterprise, so the scale is not at the same level. And we see the same pattern with agents. About 62% are experimenting with agent systems, and only 23% report scaling them somewhere in the enterprise. This distinction really matters. We do not have an AI awareness problem anymore. We do not have an AI curiosity problem for sure. In many organizations, we do not even have a problem developing pilots. We have a production capability problem. Adoption tells us that AI is present. Production tells us whether AI is useful, trusted, and durable. That is the gap that this talk is going to be about. So the production gap shows up in 3 questions. The pilot question is, can the model do this? And that's a useful question. Can it summarize? Can it classify, retrieve, generate? Can it reason through a narrow workflow? But the production question is a little different. Can the system keep doing this? That means real data, real users, real constraints, operating costs, and real failure modes. Then the scale question is a little harder still. Does this curate durable value? Not just one good output, not just one successful demo, but measurable ROI, organizational learning, continuous improvement, and trust over time. Most organizations are stuck between the first question and the second. They have proven that AI can do something. They have not yet proven that the system can keep doing it under real world constraints and pressure. That is the production gap. As an AI researcher, one of the cleanest ways to describe this is the distribution shift. A pilot often tests a slice or a friendly slice of the world. Clean data is not production data. Friendly users are not real users. A narrow scope is not a full workflow. Demo conditions are not operational constraints. One-time accuracy is not sustained reliability. And that does not mean that the pilots are bad. Pilots are necessary. They reduce uncertainty, they create momentum, and they help teams learn super quickly. But they can mislead us if we treat pilots as the success criteria and proof of production readiness. A pilot often asks, can the system succeed under favorable conditions? But the production asks, can the system handle the actual distribution of the business data? This means incomplete context, conflicting policies, unexpected user behavior, changing data, tool failures, cost pressure, accountability, and so much more. So the lesson here is not to do fewer pilots. The lesson is designing pilots that teach us something about production. This is the core framework for the rest of the talk. Production AI is not just model deployment. The model is really important, but it's just one layer. Scaling AI means building 5 systems around the model. The first being data, not just training data, but ground truth, outcome labels, failure cases, freshness, and lineage. Second is context, like what the model knows about the moment of the action, including retrieval, permissions, workflow state, policy context, and tool state. The third, and very importantly, is evals, how we know whether a system is working, not just before the launch, but continuously. Next up, controls, how we bound risk through guardrails, overrides, audit trails, permissions, and escalation paths. And lastly, but very importantly, feedback loops, how the system improves from corrections, failures, escalations, and outcomes. This is the production AI stack. And when these systems are missing, AI does not always fail loudly. It often fails silently. A recent Anthropic Claude Code event postmortem makes this look pretty concrete. The quality issues were not one simple model failure. They involved system layer changes, reasoning effort defaults, context management issues, and system prompts. The system still produced outputs, but the users saw forgetfulness, repetition, odd tool choices, and lower quality coding. Anthropic noted that internal evals initially did not reproduce these issues. That is what silent production failure looks like. It produces plausible answers, confident summaries, reasonable looking recommendations, and metrics that seem promising, until someone realizes that the system was wrong in a way that nobody was even measuring before during their evals. So when I say production AI is a system, I mean exactly this. Model capability matters, but so do context, evals, controls, and feedback loops. A useful way to think about production AI is that the value it has is multiplicative, not additive. In research, we often optimize on model capability, and capabilities matter. Better models help, better reasoning, better multimodal understanding, better tool use, all helps. But in production, capability is only one term in the equation. If the data is poor, the value drops. If context is incomplete, the value drops. If the coverage is thin, the result is the same. If the controls are weak, the system cannot be trusted. If the adoption is low, the system never reaches its true impact or the levels expected out of it. And if the cost to operate is too high, then the economics just break altogether. This is why it's multiplicative. A great model with a poor context is not a production system. A useful assistant without trust does not scale. A powerful agent without controls is not deployable. A workflow with no feedback loop stops improving. So the practical question is, which model are we using? But the better question is, what is the full production system we are building around the model? So the first foundation, like I said, is data. But I want to be super precise about what kind of data matters here. In many conversations you hear about AI, when people say data, they mean training data, more documents, more examples, transcripts, and logs. This is useful, but in production, the valuable data is often data that tells us what AI is doing wrong. So domain-specific ground truth, what a correct answer or a decision looks like in your particular environment. Outcome linked labels, not just whether an output looks good, but whether downstream it helps you resolve some issues correctly. Human corrections and overrides, they tell us about whether users rejected, edited, or escalated the AI output. Failure case data is edge case data or policy exceptions or confusing outputs that tell us when the system broke. And freshness and lineage, basically whether the data is current and where it came from, preventing concept shift, label shift, and distribution shift. The hardest data to acquire is not always the training data. It is the evaluation data for your specific domain. Think about a risk review assistant. The documents themselves are useful, but the real production signal is, did the analyst accept the recommendation? Did they overwrite it? Was the escalation correct? Did the case resolve faster? Did downstream issue emerge later? Or did compliance agree with the evidence? That kind of evidence or that kind of data turns AI from a demo into a learning system. The second foundation is context. In production, the question is not just which model, it is what does the model know about the moment it acts. That means retrieval quality and relevance. Did we fetch the right policy, document, or prior case? Permission-aware access. Is the model allowed to see this customer record, account detail, or an internal note? Is the latest information and where we are in the process available? What rules or constraints answer or action? That will be covered by the policy in the compliance context. And who is asking, what are they trying to do, and what tools are available are super important context as well. So context is not just bigger prompts. Context is live operating environment around the model. For a customer support assistant or a contact center assistant, for example, context might be customer's history, current tickets, relevant policy, product state, prior escalations, and what actions the assistant is allowed to take. For a financial operations or risk assistant, context might include account state, evidence of documents, jurisdiction specification policy, and risk rules. This could also include prior decisions and current workflow stages. If the model receives the wrong context, stale context, or even context it should not have access to, the model can appear capable and still produce the very much like an incorrect outcome. So production AI requires context engineering, not just prompt engineering, and those two are very different things. The third foundation, and I would think one of the most useful or one of the most important foundations, is evals. In production, evals are not just a benchmark. They're not just a launch checklist. They're not something you do once and move on. Evals are an operating loop. I think of them across 5 layers. Offline evals. Ask if it's launchable. That includes benchmark, regression suites, held out tests, adversary examples, and pre-deployment checks. The basic bread and butter of a ML engineering pipeline for any AI production system. Online evals ask, is it scalable? That includes latency, live error rates, drift detection, quality monitoring, and telemetry around the product. This is super important for customer-serving platforms. Then human evals, asking whether it is useful. That includes expert ratings, user feedback, task completion, and reviewer behavior, because nothing matters more than what your users or feedback perceives. And then business evals, whether it's actually useful and valuable. That includes cost savings, time to resolution, throughput, customer experience, and revenue impact. And lastly, but very importantly, risk evals. That includes compliance, fairness audits, policy violations, and harm rate monitoring. The eval set is never finished because the world that it generates the outputs is never finished. The product changes, users change, policies change, models, data, failure modes, all things change. And that is why evals have become an important part of the production operating rhythm. This evaluation becomes even more important as we move from copilots to agents. Once the system stops only generating answers and start taking actions across tools and failure modes, all of them continuously change. A chatbot can give a bad answer. An agent can take a sequence of plausible steps that ends in the wrong action. That is a different kind of risk. With agents, we are not only evaluating the final response, we are evaluating the whole trajectory, the plan, the retrieval, the tool selection, the intermediate states, the actions taken, fallback path, and how we eventually get to the final outcome. That is why agentic systems expose the limits of simple answer level evaluation. We introduce tool errors, forward batch state assumptions, we compound uncertainty over multiple states, we retrieve the wrong memories and contaminate context, they run to permission failures, they are harder to evaluate across long horizons, and they move and they need rollback and add auditability to their tasks. So the risk is not just that agents make mistakes, all AI systems will make mistakes. The risk is that the agents can make mistakes across many steps before anyone even notices. That is why this slide sits here right after evals. Agents are the stress test of production evaluations. They show how evals move from is the answer good to is the trajectory safe, useful, and recoverable. And once the failure surface expands from answers to trajectories, the next foundation becomes unavoidable, which is controls. So the fourth foundation, like I said, is controls. And I want to frame the controls differently from how they often sound or are discussed. They're not here to slow us down. They're not here to let AI move fast. They're not here to stop AI from moving fast or like becoming like unbounded. This becomes an important aspect in agentic systems, where the models may retrieve information, tool calls, update records, draft messages, or trigger workflows. Once the system can act, we need to know what is allowed to do, under what conditions, and what can override it. And that is where these controls actually come in. Access controls and tool permissions define what a system can see and touch. Human approval gates define which actions are required before review or execution, before execution's review. Policy enforcement guardrails define what the system is not allowed to do. Audit logs and rollback capability make the system inspectable and recoverable. Model and version routing controls help determine which model is used for which task and under which risk profile. This is not model bureaucracy for its own sake. It is the difference between a powerful demo and an actually deployable system. It's not a break, it's helping us steer the system in a very orderly and controlled fashion. The point of governance is not to stop production AI, not at all. The point is to make responsible scale possible. And the fifth foundation is feedback loops. This is where durable advantage comes from. The organizations that win will not simply be the ones that deploy the strongest model on day one. You've seen that in the past, it's never been the case. They will be the ones that learn the fastest from production. Corrections tell you what went wrong. Escalations show recurring failure patterns. Failure triage identifies the root cause. Was this a data issue, a context issue, an eval gap, a control gap, a workflow issue, or a model limitation? Outcomes tell you whether the system actually helped. And the eval refresh turns real world failures into better tests, better prompts, better retrieval, better product decisions, and better trading data. This is also why human in the loop is often misunderstood. Human in the loop is not a safety mechanism. And it's not just a safety mechanism. It is a data generation mechanism. If a reviewer corrects an output, overrides a recommendation, flags uncertainty, and escalates a case, that should not disappear into some log that nobody ever reads. That is a signal. That is a very, very important signal. And when the system is designed well, these signals improve the data, context, evals, controls, and the overall workflow. And that is why this is the production learning loop. And that's a very important step in this whole pipeline. And now the framework becomes pretty practical. Before we scale anything, we should be able to answer a few concrete questions. So to make this practical, here are 5 questions I would want any team to answer before they take an AI system into production. First, what workflow or decision improves? If the business surface is vague, ROI will be vague. AI has to attach to a real workflow, a real decision, a real operational outcome. This is also where the data question starts. What ground truth do we need? What are the outcome labels, corrections, and failure cases that tell us whether the workflow is actually improving? Are we improving the overall decision or not? Second, what context does the system need? Is it allowed, and is it allowed to use that particular context? A model can be highly capable and still fail if it sees stale, incomplete, or unauthorized context. Third, how do we know when it is wrong? This is the eval question. If we cannot detect incorrectness, wrongness, we cannot safely scale. And if we only measure success at launch, we will miss how the system behaves when the distribution starts changing and more users on board and bring new real world data into the system. Fourth would be who can override, pause, or stop the model. This is the control question. This is the control question. Production systems need authority, escalation, and stopping conditions to know when to scale up the model, when to stop, or when to scale back certain aspects of it. Fifth is how does every failure improve the system? This is the feedback loop question. Failure should not be an incident, it should be coming from a learning signal. Together, these questions from production readiness tests, they map back to the same foundations we discussed before. And if a team cannot answer these, it may still be ready for a pilot, but it's definitely not ready for a production environment. And that is a distinction that matters. Pilots are where we test the possibility. Production is where we test repeatability, and scale is where we earn durable value. So let me close this with a shift I think matters most. The old question was, can the model do this? That was the right question for an early phase of generative AI. Can the model summarize? Can it close? Can it code? Can it reason? Can it retrieve? Can it use tools? And can it understand all sorts of input, including multimodal AI? But the new question is different. Can the system keep doing this under real world conditions? With messy data, with incomplete context, with changing users, with policy constraints, with cost pressure, with real risk, monitoring, accountability, and feedback. The durable advantage will not come from deploying AI just the one time or launching more pilots. It will come from building systems that allow AI to safely, measurably, and repeatedly improve over time. That is the shift from pilots to production. The pilot era taught us what models can do, and the production era will reveal what organizations can operate. So that's it. I'll pause there and open it up for questions in a moment. But before that, I wanted to give a heartfelt thanks to the Argyle team for bringing this summit together and inviting me to be a part of this conversation. And thank you all for your time and attention today. I hope you have a great summit with thoughtful, practical, and valuable experiences. Back to you, Michael.
Thank you, Ritvik. This is a wonderful presentation. We appreciate you being here. As a reminder, audience members can still enter questions, and we're now going to review some of the questions that came through. Okay, so let's look at our first one. When deciding which AI use cases to take into production, which criteria should we use to prioritize what's actually worth scaling?
That's a great question. So it definitely depends on the domain you're coming from. Each domain has different criteria that we can look into, but I would say out of the 5 different modes I looked at, data, control, feedback loops, evals, and context, I think all of them in different parts of the lifecycle matter, but to scale up, you definitely need to start in that particular order of the loops. You need strong foundational data to even be able to develop pilots. But when you're taking it to production, I believe the most important factor here will be evals. Because if you cannot ensure certainty when you're actually scaling to customer data, then it's really difficult to ensure success criteria being met when a larger customer base is using it. There's 2 ways to think about it. One is that you're looking at customers who will be using it a few days from now, and the other one would be the customers who will be using it on the day off. So when we look at the customers who are using it on the day off, they might meet your success criteria immediately. But when you think of customers who are looking at it for, the distribution will entirely shift. People will be maybe communicating with your agents in a different way. The natural language keeps evolving, and your model might not be able to handle it right off the bat. And that's where the feedback loop really helps. It brings all the conversation back to how we can continuously improve and scale up the system. So I would say like all these 5 categories really matter, but depending on the life cycle of it, you should prioritize which particular domain fits you the most.
Thank you. Our next question, from a technical and operational standpoint, how important is data readiness compared to model performance when moving into production?
That's a great question. I would think from a technical and operational standpoint, data readiness is super important because model is something which can iterate over time, and model, given the compute capacity we have these days, improving the checkpoints, training models further with better and increasingly improving data is possible at a much faster cadence. But I do believe like if we don't have high quality data, which has been annotated with the right amount of labels, the outcomes and everything, it's difficult to just have a model iterate and improve. A model is only as good as the data and the context it has. So yeah, data readiness is super important compared to model performance. If you have me weigh between the two.
Excellent. Thank you. Our next question, do you see AI scaling as primarily a technology challenge or more of an organizational and cultural transformation challenge? That's interesting.
That's an interesting question. I would think both. So I think primarily as a technological challenge, I think we are getting there. It's something which will iterate newer models, newer technology, newer underlying frameworks that we have built these generative AI tools on are scaling up. So it will be a technological challenge, but I think we are, as an industry, the software industry is moving pretty fast towards converging on the good ways, and we're moving to the next steps pretty quickly and pretty well. So I think it's lesser of a technological challenge. It's an interesting technological challenge because things keep changing so fast and iteratively, but it's definitely a bigger organizational and a cultural transformational challenge because a lot of scale organizations which have been kind of set in their ways, adopting AI and bringing that into production is definitely challenging because you have to kind of change the way certain aspects work, the way you interact with customers, and it takes some shift, and it definitely adds some level of organizational shift there. And the same applies with cultural transformations. It's a point about not being used to a new piece of technology that is continuously evolving before you even get on board with a certain level of it, and then it just keeps jumping the hoops to the next and greater levels altogether. So yeah, making sure that you and the organization are able to keep up speed with the latest and greatest out there is definitely challenging, but it's definitely worth the time and energy spent into this new piece of tech because this is taking over the world for sure, and it's a very positive thing.
Thank you. So our next question, a lot of companies have successful AI pilots, but struggle to scale them. In your experience, what's usually the biggest gap between pilot success and production reality?
Yeah, perfect. I think that's exactly the entire talk's point of view. So I believe there is the biggest gap here would be looking at a very narrow term path. When we build these pilots, we take very clean data that we know is the input and the output from the models. We know this will be the context, and we often test these pilots within different companies with data that we might be getting from uh, our annotators or our teams within in-house. You might be using some data from a very particular vendor or a very particular customer that you're relying on. So we start building these niches and like small pilots around a small amount of data, a small amount of context, small amount of feedback, but we never really scale that up. When we look at these small pilots, we tend to over-optimize on them. As you keep over-optimizing on these sort of small limited number of constraints, you can definitely achieve a great state, and the pilots may look absolutely great. And probably if you scale up within that restrained environment, it'll look really well and it'll work really well as well. But when it comes to real world and like more customers, more data, and different variations, these models don't really generalize very easily. And that's because we have trained them to be very specific to that niche. Not every customer, not every customer's customers, or if you work in a B2B environment, or even like other form factors like data, the context keep changing, keep evolving. So when the pilot is not trained for it, it cannot directly scale. We need to add more nuances, more variations to it to make that pilot a bigger pilot and like keep increasing the size and scope it can handle. And only when you do this more iteratively can you reach like true production size. It's not a 0 to 1 in one day sort of a problem for sure. It's a difficult challenge, and a lot of companies do struggle with it. But yeah, the goal is to keep working, keep taking into account those feedback loops, and eventually get to the point where you can scale up to the full level.
Thank you. So in our final minute, we have one question left. Looking ahead a few years, do you think companies that succeed with AI will be the ones with the best models, or the ones that build the strongest systems around deployment, integration, continuous learning?
That's a very great and very fair question. And I would say there will be different schools of thought on this for sure. Where on one hand, we do need great foundational models that a lot of companies are developing to get to the level where others can actually, smaller companies or different teams can build on these foundational models and get to the final line. I would say not everyone is in the same boat, or not everyone has the same compute to develop these larger foundational models from scratch. So depending on which side of the coin you're on, I would say the strongest systems will be around both foundational models that you either build or rely on. But at the same time, how do you deploy these particular versions or variants of the models yourself? How do you learn from your own customers? How do you learn from the integrations that you're doing with different third-party vendors? Uh, the latter being super important, because when you have your own customers, the base foundational models will only be good enough to a certain extent. It really depends on how you integrate with your own customer data, your own success criteria, and like keep iterating over it. And then only I believe the production models for your own company can do really well. So yes, I would lean more towards the latter, depending on the point of view you're looking from.
Thank you, Ritvik. This was an excellent keynote, and that's all the time we have for this session. I also want to thank everyone else for joining us today. Now, this session, along with all of today's content, will be available on demand following the event. Our next session will begin at 11:35 a.m. Eastern Time, which will be a panel discussion titled AI that Operates Across the Enterprise. Please remain on the stage, and the next session will begin automatically. We look forward to seeing you there. Ritvik, thank you so much for being here.
Thanks, Michael. Thank you, everyone. Have a great summit.